Hi, fifth grade. We're going to work on some math today. So please grab your fifth grade math home review packet. And we're going to turn to day 9. We are still in day 9. So we're going to be on this page in day 9. And we're talking about prime and composite numbers. So let's get started. Day 9. Question 2. Draw a model of a prime number. Explain why the number is prime. Well, we just did question 1, and we got 3 prime numbers. We got 2, we got 13, and we got 43. So I'm going to choose to draw 13 as a model. So what I've done here is I've drawn 13 circles. Now, how can I explain that this number is prime? Well, I could write that 13 has exactly 2 different factors, 1 and itself. I could also draw a factor tree with 13. We can break 13 down to 13 times 1. Day 9, question 3. Which of the following statements are true? Our first statement says a prime number has exactly 2 different factors, 1 and itself. Well, I've written our prime number definition over here, and within that definition, it does say that a prime number has exactly 2 different factors, 1 and the number itself. So our first statement is a true statement. The second statement says a composite number can always be represented by 2 or more arrays. Let's test this. I'm going to use a pretty simple composite number, 6. We know that 6 can have the factors 1 and itself, 6, 1 times 6. We also know 6 can have the factors of 2 and 3, 2 times 3. So therefore, I can do an array demonstrating 1 times 6 by just drawing 6 small models in one row. I can also draw another array representing 2 times 3, which would be Therefore, this demonstrates that a composite number can always be represented by 2 or more arrays because it depends on the factors. So that is true as well. A prime number is always odd. Well, let's look. Over here, we know all even numbers, except for 2, are composite. This told us that 2 is prime and 2 is even. Therefore, there is an even prime number. It is 2. So all prime numbers are not all odd. This is a false statement because of the number 2. The number 1 is neither prime nor composite. That is true as well. If you look over at our definition, a prime number is a natural number other than 1. One is not included in the prime numbers. However, when you factor 1, you can't get anything other than 1. So this is also true. Day 9, question 4. Which list contains only composite numbers? Well, let's just start with our first list. We've got 29, 1, 11, 31, 47, and 3. Well, just off the bat, I know that 3 and 11 are definitely prime. If I go back through, I find out that actually most of these are prime numbers as well. But I absolutely know that to get to 3, there are only 2 factors. There are 1 times 3. So that list is immediately out. Our next list, 18. Oh, we know 18 is composite. But then we get to 5. There are only 2 numbers that you can multiply to get to 5. 1 times 5. So 5 is prime. So this guy's out. Our next number, we've got 54. Well, over here, it tells us that all even numbers are composite, except for 2. So we know 54 is composite. Then we've got 63. Well, if we remember our multiplication facts, we know that 9 times 7 equals 63. So that means 63 is composite. And then we go on to the number 9. We know that 3 times 3 equals 9, which means it has more than 2 factors, so it's composite. Let's keep going. We've got 15. 3 times 5 equals 15. If we were to skip count our 3's, we would hit 15, which means 15 has more than 2 factors and is composite. We've got 27 next. Let's see. What if I skip counted by 9's? I would end up 9 times 3 equals 27. Again, it has more than 2 factors, so it is composite. Finally, 49. Our last number. We know if we skip count by 7's, will we hit 49? Yes, 7 times 7 equals 49. Therefore, our third list have all composite numbers.